What's up, everyone? Welcome back. Patrick here. Moving on to the next example. This is a communication question in the Unit 1 test for advanced functions. So we have this function f of x equals 3x squared minus 1. And we have to find the inverse of it in 3 different ways. And as you know in the lecture videos, we went through finding inverses in different ways. We did it graphically, for example, where we would reflect the line over the y equals x line, right? Basically interchanging the x and y values. We can do it algebraically, interchanging the x and y values and then isolating for that new y value. And then we could also do it with words, where we describe what's happening to this input x to get this output f of x, or this output y. And then the inverse, we're going to be going backwards and then switching all of the operations. So I'm going to go through all 3 methods in this particular example. So let's start off graphically. Notice that this is a quadratic 3x squared minus 1. Now notice here, this is basically the x squared parent function vertically stretched by 3 and then shifted down by 1. So we know that the vertex is going to be at what, 0 and -1, right? You could also rewrite this quadratic as like 3x minus 0 squared minus 1. You could picture it in vertex form, and you could tell the vertex is at 0 and -1. So what I'm going to do is I'm going to make a table of values for it. I'm going to put that vertex in the middle, and so to make it symmetric, I'm going to pick 2 x values to the left. So let's say like -1, -2, and then 2 x values to the right. So let's say 1 and +2. And then the y values we get here should be symmetric. So if I plug in these x values into this function, -1 squared is 1, times 3 is 3, minus 1 gives us 2. And if I plug in -2 here, -2 squared is 4, times 3 is 12. 12 minus 1 gives us 11. If you plug in 1 and 2, you would get these same y values, 2 and 11, like that. And so now that we have a table of values for the original function, we can make a table of values for the inverse, right? So we could just interchange the x and the y values. So now the inverse would have a point 11, -2, 2, -1, -1 and 0, 2 and 1, and then 11 and 2, like that. And now we can basically graph this inverse. We could actually graph both on the same graph. I'm going to just do a quick kind of rough sketch of these graphs. If you want to use graph paper, you could plot these points in a little bit more detail. So you know what? Actually, I'm going to draw these separately, not on the same graph. So if we were to plot these points, we'd have the vertex at 0, -1. We'd have 1 and 2, -1 and 2, and we'd have like 2 and 11 up here, -2 and 11 up here. So basically we have a quadratic that it should be a little bit more curved. Anyway, you get what I'm saying. That's how the quadratic, that's how the original function would look. And so now, if we were to graph the inverse, we know that the inverse of a quadratic, it's always going to be a sideways parabola. And then the sideways parabola is going to be the transformed vertex. So now instead of the vertex being at 0, -1, the new vertex is going to be at -1 and 0. So it's going to be like over here. 2 and -1, that's going to be like down here, and then we'll have 2 and 1, that's like here. 11 and 2, let's say over here. 11, -2, like that. Okay, so it's basically sideways parabola that would look like that. Okay, so these are the general shapes that you should get if you were to take these points and graph them on graph paper or with a more scaled axis than the one I have here. Right, so that is one way to find the inverse, is to perhaps get the table of values for the original function and then switch the x and y values, and then you could plot it. And basically what's happening, if you remember from the lecture videos, when we are switching the x and y values, graphically what that means is that we are reflecting all of the points on the line y is equal to x. So this like 0, -1, if we reflect it over this line y is equal to x, we would get that new point over here, which would be -1 and 0. Okay, same for these other points, right? They're just getting reflected over this line in order for us to get this new sideways parabola here. Okay, so that is one way to do it. You could do it graphically. Yo, what's up? Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit that have video solutions. Number two, if you feel like you need tutoring at any point, hit me up. I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Now the next method we're going to do is we're going to do this algebraically. So here we got y is equal to 3x squared minus 1. If you remember, what's the algebraic process? Well, we basically first interchange the x and the y values. And then what happens is we have to isolate for this new y value. And then whatever expression we get after we isolate for the new y value, that's going to be our inverse. So what I'm going to do, bring the -1 over. So we'll have x plus 1 is equal to 3y squared. Then what we could do, divide both sides by 3, right, to get rid of this 3 here. So we'd have x plus 1 over 3 is equal to y squared. I'm actually just going to put the y squared on this side, and then we'll have x plus 1 over 3 like that. And then to get the y by itself here, we just square root both sides, right? So that new y value, once we isolate for it, it's going to be x plus 1 over 3. And because we're square rooting this, this is going to be plus or minus, right? That plus or minus, that's where we're getting that sideways parabola. There's going to be multiple y values. There's going to be a pair of y values for every x value. All right, so the inverse is basically plus or minus x plus 1 over 3, right? So if you were to take this relation and if you were to graph it, you would basically get that sideways parabola that we graphed earlier. All right, so we could do it algebraically. So that was the algebraic process right there. Now we can also do it in words. So let me erase this stuff here. What we could do is we can describe this function in words. Now, if you remember from the lecture videos, what I like to do, so let's start off with the function, is I like to first say, okay, we're going to have an input, which is our x value here. And what are we doing to that input? What we have to do is make sure we're going through bed mass properly. So the first thing we do, like let's say we were to input a number here for x, let's say like 2. The first thing we do is we square it, right? We take it to the power of 2. So we could write squared. I'll just say power of 2, right? That is the first operation that we're going to do. Now, after we take it to the power of 2, what do? We multiply by 3, right? We multiply it by this 3, and then we subtract 1, and then we end up with our output. I'm actually running out of room here on the side, so I'm going to split that up into 2 words, output, right? And that's how we get our output here, y, right? So we have our input x, take it to the power of 2, multiply it by 3, subtract 1, and then we get our output y. This is for the function. Well, now for the inverse, what's going to happen, let's actually do it in a different color. What's going to happen is with the inverse, you're going to start on this side. So we're going to have an input x, and you're going to go the opposite way, and then you're going to do the opposite operations that are listed. So the opposite of subtracting 1, you're basically going to add 1, like that. Okay, So you're going to add 1, and then instead of multiplying it by 3, you're then going to divide by 3. And then instead of taking it to the power of 2, the opposite of that is to basically square root it, or take it to the power of 1 over 2, right? If this was a power of 3, the opposite of that would be third rooting it, right? Taking it to the power of 1 over 3. If this was a power of 4, the opposite would be taking it to the power of 1 over 4, taking the fourth root. But because it was a power of 2, we're just simply square rooting it, and then we end up with our output, right, which is basically the inverse. And what I want you to notice is, notice that these descriptions that we went through here in red, they actually match the equation that we got when we did it algebraically. Notice we have our input x right here, and then we add 1, right? We're working with that numerator first, and then after that we're dividing by 3, and then once we have that whole value, we are square rooting it, right? And then we end up with our output. So that is another way to find the inverse. You got to take the function, write out the order of operations in words, and be careful with BEDMAS, right? Using BEDMAS to get to your output y. And then to get the inverse, you start at the end, and then you go the other way, and then all of the operations, you basically do the opposite. And if you also find it algebraically, you can check, or you can confirm that these descriptions here match the order of operations in your equation as well. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.